Okay, we're going to look now at confidence intervals for paired means. So example 1. A study was conducted to investigate the effectiveness of hypnotism in reducing pain. Results for randomly selected subjects are shown in the table below. Lower score indicates less pain. The before value is matched to an after value. Are the sensory measurements, on average, lower after hypnotism? We're going to run a 95% confidence interval and interpret. And so we have subjects A, B, C, D, E, F, G, H, I, J. So subject A before was 6.6, after 6.8. B, 6.5, 2.4. C, 9.0, 6.4. D, 10.3, 7.5. E, 11.3, 8.1. F, 8.1, 6.1. G, 6.3, 3.4. H, 11.6 to 7. I, 7.0 to 5.3. And J, 8.0 to 6.6. Okay, as usual, we need to verify the conditions before proceeding. So our first condition is the data must be paired in some way. So often this is in the form of before and after, or pre and post test. It could also be in the form of a, husband, wife, brother, sister, which are clearly not independent. So usually we'll have two groups, and they are somehow paired. Sometimes it's the same person with the before and after, or sometimes the two people are related to each other in some way. Okay, independence. Wait, what? I thought we said we had to have dependent, not independent. Our pairs are dependent, but the differences must be independent of each other. So, for example, subject A's difference has nothing to do with subject B's difference. SRS, so simple random sample as usual. We can't have too big of a sample, and the sample needs to come from a nearly normal population, or N is bigger than 30. So our N is not bigger than 30, so we need to actually test to make sure the distribution could have come from a normally distributed population. And we'll do that now. So you're going to press, step 1 is to press Stat, select Edit. You're going to put the data. I'm going to put the before in L1 and the after in L2. You can reverse that if you want. This is how I'm going to do it. So we need to compute the differences in L3. Now we could do this by hand, but I'm going to let the calculator do this. Scroll up to L3, type in L1 minus L2 as shown, and press enter, and you'll see the differences appear in L3. Now this is not dynamic. If we go in and let's say we made an error in L1, that's instead of 6.6, that was supposed to be 6.2. If I put that in there, it's not going to make that difference change. So you would need to redo that difference. Now we need to create some visual displays to check the nearly normal condition. And I'm going to show you here, we got a histogram, box plot, normal probability plot, and we've seen all these displays before. So if you need, okay, things look pretty good. Nothing, we don't see heavy skewness, slight skewness maybe. The normal probability plot is roughly linear, so I think we can proceed with the t interval. So press Stat, select Test, number 8, t interval. We're going to select Data this time because we've actually put the data into L3. Make the frequency 1, it should already be at 1, and we're running a 95% confidence level. So we see our interval, along with the sample mean difference and standard deviation for the differences. So our mean difference was 2.51, standard deviation of that was 1.3787, and our interval is from 1.52 to 3.50. So we are 95% confident that the mean difference on the pain scale is between 1.52 and 3.50. So one little note here, when we went into test on that very first step, it may have been tempting to do a 2-sample t interval. Now we'll get to those, but that means 2 independent samples, and we have 2 dependent samples. So we run a t-test on the differences. Something else that needs to be mentioned is that list, make sure you make that L3. It's probably defaulted to L1, so change that list to whatever you put the differences in. In mine, it was L3. Another interpretation is we are 95% confident that the hypnotism reduces pain by, on average, 1.52 to 3.50 points.